Hello and welcome. I'm Joanna Junak, and in today's program, Roberto Sussman will tell us more about the impact of thermal processes and the composition of e-liquids on aerosol formation during vaping. Roberto, what thermal processes take place during vaping and how do they affect aerosol formation?
Vaping essentially is an exchange of energy. That is, you supply some energy and this energy is absorbed, not all of it, there is a residual part, and it is in a cycle. Every puff is a cycle. So the energy that you supply is electric energy in the form of heat. Heat is an energy. It was thought before many years, centuries ago, that heat was a substance. It was called caloric, but it is not. Heat is just an energy. It is essentially when one molecule is pushing another one, another one, another one. It is like if you have the cards, you push one card and all the cards start falling. So heat is energy. You supply with a battery, you supply electric energy. The electric energy is transformed into heat, and this energy you supply to the coil, right? Now, the coil has a wick, right? The wick absorbs liquid, and the coil will vaporize this liquid. That is, it is liquid, it will turn it into gas. It's a vapor of that liquid, and it will heat it. But it has to heat it to a temperature that's called the boiling temperature that depends on the specific mixture. And you also need a amount of energy that has to be absorbed in order to vaporize it. This is called the latent heat of vaporization. So it's not sufficient to raise the temperature of the liquid in the wick to raise it to the boiling point. This is necessary but not sufficient. You still, once it's there, some energy that was supplied will be absorbed to generate the vapor, right? Okay? And then almost simultaneously, and this is what makes vaping complicated because the processes are almost simultaneously with this vaporization, it is the user inhaling. So physically, the inhalation is called thermal convection because you are, or it is also called forced convection because you are forcing the vapor to move, right? And as it moves around it's very similar to a kettle. It's like the kettle was a snout. Here it is a conduct. It is a cylindrical conduct. See, you can see it in here, the cylindrical conduct. So the user inhaling means transporting, is forcing the convection of this vapor to the mouth, right? And of course, as I explained in the last time, when you have this vapor, this is gas that is cooling. Cooling means that little bits of gas will become liquid again. And these are the droplets that are carried by and this is the aerosol. Now, you have energy that entered and energy that was absorbed, right? This amount entered, and some of it was absorbed either in the vaporization or in the convection. But not all of it was absorbed. That's impossible because it is not a perfect system. It is close to thermal equilibrium. If it was in perfect thermal equilibrium, then it would be 100% efficient. But we know that there is no machine that is 100% efficient. So there is some residual energy that remains inside of the atomizer. This energy it can do many things. For example, if it is hot vapor that remains there, it can condense back to the liquid. It can also heat the bulk liquid, and it can also heat the walls, right? You feel it like if you puff an e-cigarette very frequently, you will start feeling that it gets hot. Why? Because you are not allowing time for this extra energy to relax. What is the meaning of relax? To be absorbed, you have energy like that, and you need it to relax. The molecules move slowly, and they reach an equilibrium with the rest of the system, the liquid, the walls, etc. Right? And the next puff, you repeat the cycle, right?
And what are the main components of e-liquids used in vapes? And how do they affect the boiling temperature?
That's a very, very interesting question. Well, essentially, the liquids have two solvents. Uh, Solvents means that you dissolve everything on them, and these are propylene glycol and what is called vegetable glycerin, but its technical name is glycerol. And you also have nicotine and flavorings, these flavor chemicals. Like if the liquid is banana, that doesn't mean you have pieces of banana there. You have chemicals that mimic the fragrance. People talk about flavors, but more we're talking about fragrances. But anyway, it's very much connected what you smell and what you taste. And so, in any case, every mixture, the boiling temperature will depend on the composition of the mixture. And you can alter it. For example, if you put a little bit water in the liquid, it will boil at a different temperature, lighter temperature. Uh, it, what you can say is that if we have only propylene glycol, it's a very light molecule, and the boiling temperature is 180, right? So if you only had propylene glycol, it would be 108. If you would have only glycerol, it would be 288, right? So anything else you can put will be in between, right? You can, for example, if you put a lot of flavorings and ethanol or different levels of nicotine, it will be some intermediate temperature between 180 and 288, right? And the more propylene glycol you have, the lower the boiling temperature in this range, right? But these are the temperatures, and the reason is that once you have this mixture, you have different molecules. And so the boiling process, which essentially in the end it has to do with the interaction energies of the molecules. And as I explained before, when there is vaporization, some of the molecules they are bound by forces, right? You increase the temperature, so you make them more energetic until they break. But this is when you have one type of molecule. Now imagine you have many types of molecules, right? So the process becomes much more complicated. In fact, it is very complicated. It's not a formula that I can write in. No, if you have a complicated mixture like this one that has 5 or 6 ingredients, two solvents and solutes of other type, it is complicated. You have to do with computing to find out the right It's not so easy. There are some calculations that give you orders of magnitude, but it is a complicated process, and it is between those temperatures.
Stay tuned for the next part of our science series coming in a couple of weeks.